Okay, so I've gotten this question a few times, so I'm going to try and tackle it. It was how to control other parameters inside of Unreal using DMX. I don't want to poach too much from my Unreal Fest talk, but I do want to give some ideas as to things that work, some things that work better for other situations. So let's get started, and I'll try and go through this as quickly as possible. Again, I'm going to do this live stream style, so if there's errors, I'll just try and keep going, and I apologize in advance. So I've already got my DMX proven here. I'm running a little CamSys session over here. So if I, turn some things on, you can see input. So that's number one. Make sure you're getting DMX input before you even start, or this will be probably harder to troubleshoot. I'm using one 8-bit channel as dimmers, and just RGB 3 8-bit channels called color add _R. On G and B, and then I just patched a few of them, and that's all I'm going to use in this example. So the question was about controlling a directional light, but that wasn't necessarily as straightforward, so I'm going to start even simpler, and then we'll kind of work our way up to that. So we'll start with a spotlight and just kind of go from there. So I'll just change a few things to make it a little more obvious what's going on. And so we have this nice virtual volumetric spotlight. So how would we get DMX to talk to this? Well, the way, first I'll set it to movable because I'm going to probably drag it around. I don't want to get yelled at. But most people would probably try and tackle it this way, where you just create a blueprint, and this is perfectly valid. And so we'll just call it spot DMX, and we'll go ahead and create this. And then we'll go over here, our event graph, and start playing around. So if you've played with Unreal at all or followed any tutorials, most people will tell you to avoid using event tick at all costs because it can get very expensive later on. And luckily, DMX has a really good function for this already, which is to bind to on protocol receive. So if I just start typing in on proto, if I can spell it correctly, protocol, and it's not going to show up for context sensitive. But I want this assigned to on protocol received. And what this is going to do is it's going to automatically generate a custom event that's bound to this on protocol received, meaning anytime any protocol is received, do something. This has to be hooked up to the DMX subsystem, so you can just hook it up to that node, and this should be good to go. Now, anytime any DMX is input, this will fire, and we can tell it to do stuff with it. So the first thing I'm going to do is I'm going to get my DMX function values. I'm going to do it this way and then show you another idea for this. This requires a patch. So if I go get DMX fixture patch, I'm going to specify a specific library and a specific fixture. And the reason I'm going to do it this way is because if I do this and specify it, I get this nice little expose functions, and I can see exactly what this fixture has. And then it becomes really easy to write the logic. So all I really need to do is set the color of this thing. So literally if I drag off and I go set light color, I'm going to see I get the spotlight component option. Since it kind of knows what's going on, I'm going to pick that. So it's already linked this component over here to my target. If you didn't do that, if you didn't pick that one, you can always just drag this out and hook it up manually. And then the last thing I need to do is hook up the light color. Now, since the light color is already 0 to 255, I don't need to do any conversion between DMX numbers and like float numbers, but I still need to convert ints to floats. So if I just connect it, it's going to do it for me automatically, which is really handy. And then we can just kind of make it a little bit prettier. And so this in itself is enough to probably get this done. So if I go back, I'll save my scene, I'll go into play mode, I have the spotlight, it goes out when it sees that DMX is kind of coming in. If I just, I'm going to grab my CamSys here, and I'm going to just start punching away on colors, and you can see it's changing colors. And this is good enough to get this, done. And if I were to start dialing them down, that's going to affect like its overall, levels as well. When you're just using color. Now this is great. However, this is very, very limiting, because if I wanted to make another one of these, and a lot of times you just alt drag off and make another one. Well, now I just have two copies that do the identical thing. And if I go in and edit the blueprint, like it's just going to, and change this, it's going to change it for both because they're both referencing the same thing. So at some point you can, some people might try to create children and override certain parts of it, or more often than not, what happens is you end up getting just a ton of blueprints in here because people just duplicate this and change it. And that kind of defeats some of the functionality and the purpose of using blueprints, which is to automate things to make them go a little bit faster. So let's look at another way that this could work that would actually be maybe a little bit better. So instead of specifying our fixture patch ahead of time inside the blueprint, what if we wanted to specify it on the actual blueprint itself, just like the way the inbuilt fixtures that we supply works? So to do that, we need to add a DMX component. So we'll add DMX component over here. I'm just going to leave it alone, the naming. And then here I could set a default, but I'm not going to do that just to kind of go through this process. So if I do this, then I'm going to get fixture patch, and I'm going to get a different node. And even though they're named pretty much the same, this one's referencing the actual component. This one's like hard referencing something in the patch. So in this case, if I were to unhook this one and plug this guy in, as soon as I recompile this and save it, I'm going to end up losing this functionality here. And the reason behind that is it doesn't actually know what this is. Once I go into runtime, then it will know, but before that time, it doesn't know. If I hit expose functions, I'm not going to get anything here. And that's just because it can't know. There's no way for this node to know what's on this side. It could be anything. And so we need to tell it something slightly differently here. So this function map, instead of it being something that we know, what we're going to do is we're going to use some find nodes. And so what I'll end up doing here is I'll end up going find. So map find. And what it's doing now is it's looking for a string that is going to match. And once I get that match, it's going to output that value here, right? So we talked about this. I mentioned it really, really briefly, but inside this fixture type, what it's looking for is this. So if I just copy that and paste it into here, now I have the color R, right? And then basically I just need 2 more copies of this thing. Now the way the find nodes work, it doesn't know kind of what should be in this spot until you hit compile. So now that I have that, I can just change it to B, and then I'll change this last one to G. Now there's probably a dozen other ways we could do this. We could create variables and create like tables for these types of things, but I'm just trying to show you like a super basic kind of way that this could be made slightly more functional. And so this essentially does almost the same identical thing. Instead of using a specified fixture patch, I'm going to find it, and then I'm going to use that to affect this spotlight here. So if I compile this and I go back, now what I'm going to get on this is actually I have a DMX component, so I can specify and say this one is going to be RGB1, and I could say this one is going to be RGB2. And right away you can kind of see what the benefit of something like this would be. Now I don't need to create multiple blueprints to essentially do the same thing. So if I pick this one and go red, and then I pick this one and go amber, I feel like I'm off by a channel somewhere, but that's kind of the idea that I'm looking for. Is I want it to RGB. Yeah, see, if I would have done this correctly, that probably would have been a little bit better. But right, so I enter play mode, bring this back up. I go to the first one, I go red, and then let's do this. And then if I grab the second one and go amber, now I'm kind of getting more what I would expect out of this, right? So that is a slightly better way to handle this. And I think this will in general be a good strategy for doing this kind of thing. However, you can probably tell that like there are some better ways to maybe handle this as well. You wouldn't necessarily want to have to get this and do this every single time. You could have some kind of master blueprint or in your player controller or something else that would actually do the getting and just pass in like the fixture patch to this. So you don't have to keep doing this every time. But for a small amount of objects, it's not going to be too bad, honestly. And it's still way better than having dozens of blueprints stuck inside here, because I can definitely keep going and just duplicate this and create more and more of these. But so now that we've got that kind of as the base for setting some of these things, let's take a look at how I ended up dealing with the spotlight, the directional light. So the directional light was somewhat interesting because it's its own actor type, and I was getting some trouble trying to reference this component. So what I ended up actually doing is just creating my own blueprint. So I went and did blueprint class, and in here I just picked a regular actor instead of doing there is a type called directional light. So when I did this, it kind of already came with some things that weren't didn't want to work as well as I was hoping. So I just created my own. And again, the reason behind this was fairly simple, that if I tried to get a reference to this, if I do it from the actor, it wasn't actually allowing me to use this. It wasn't recognizing it as a light component. It was recognizing it as something else. So that's something I might need to investigate further, but I basically did the identical thing, and so I kind of already had laid out here are two different ways to do it. So I ended up going with the same two ways that we just kind of went over in the spotlight. So same thing. Now I can do this same idea here. I can set on this what I want to listen to. So then if I hit play, now when I do RGB1, now I should be affecting the directional light in this scene. But let me see what I did here. RGB1, that's fine. I feel like I removed something. Set linear light color, directional light, that's fine. All this actually looks good. So what? Here. Let's see. Let's see if I can get an idea of what I'm missing here. So it goes to white, and then I go red. Okay, so basically what I'm noticing is I was barely seeing this color here, and why that is because the directional light is not really aimed very well. So if I go and I were to play with the rotation on this, it will be much more obvious what's happening. So now we get our nice red color, and I can change that directional light. So that's one way we could deal with the directional light. Another way we could do it, if we wanted to use the actual directional light, actually that you kind of just drag in from the modes thing, is in this case, actually I only need one of these things. What I'm going to do is tackle it from a player controller. So what I did is I created a new game mode, and so basically if you go blueprint class and you type in game mode, I just created a new game mode, and then I created a new, if you do the same thing, it actually is right here and right here as well, so you can do game mode or player controller, and so I created a new player controller as well, and I named that one DMX player controller, and I named this DMX game mode. So to enable using this inside my world settings, I did an override. Typically this would be at none. I set this to DMX game mode, and then I assigned this DMX player controller as my player controller class. So normally this would just be set to player controller, but I'm going to use mine. All right, so now I'm overriding that just on this level, because what I see a lot of people try as well is they'll just go into the level blueprint and throw everything in there, and then you can only use it on this one level. So if you create a new level, you got to copy and paste, and the player controller can work on both. So let's just open it up and see what's in it. So the view inside the viewport, it's literally just a camera. That's the only thing that's actually visible. But here's kind of what I set up, and literally this is just the exact same thing. In this case, I specified exactly which fixture I wanted. So I said listen library RGB1, and then now I'm going to use a different method to get what I'm looking for. So instead of actually hard referencing the directional light or some other actor, I'm actually going to use a get all actors of class. So I'm going to try and get every directional light in the scene. Now I could, in most cases, you're only going to have one. I think you can actually really only have one, since it's a special type of light. But if you had lots of spotlights and you wanted to just grab them, this would equally work. But in this case, there's really only one. I'm going to use a for each loop, go through, and I'm going to get the light component, and then I'm going to set it in the same manner as the other one. So what this should do is once I gotta hook this up here, and now once I hit play, and the whole thing goes dark because there's actually nothing, there's no light, right? So if I grab this and I go white, now it's going to do that, cyan, blue, pink, amber, so on and so forth. And so that's another way you can kind of tackle this, and I like this player controller approach just because I could pack a bunch of stuff in here and then put it in another level, and it's only one asset in this case. So just some thoughts on that, just to kind of try and think more in a programmatic like kind of fashion, because sometimes specifying things with hard references and level references and things, it can get easily broken, and it's nice to be able to think that I could take this and use this in another level. So for instance, with my BP point light here, I mean, literally I can just drag it in, and then all I have to do is, go to my DMX component and tell it what it is, and there we go. Like now it's ready to go, and I can do the same, identical thing where I, play with that point light. And in this case, I'm also affecting the directional light. So kind of an interesting thing there. So I'm actually going to go back into the player controller, disable it so there's always a little bit of ambient light in here, just for demonstration. And I can see my point light's doing, the color, and the other directional light's not affected. So those are a couple of ways to kind of tackle colors. So now let's maybe think about, and that's for lights. So lights, pretty simple because they actually have this light color and it's already 255. But what if it was something else? What if I wanted to affect an object that had a material on it? So I made this cube blueprint, which is literally just a cube with the same thing, DMX component on it. But let's look inside and see what we have here. Again, I'm doing pretty much the exact same thing. However, there is a kind of a very important difference about how I'm actually trying to set the value on this. So what I've actually done is the beginning part is all the same. So we're going to get the patch from this DMX component. We're going to do the color, the fine to get the RGB. But instead of, there is no set light color because it's a mesh and it just has a material attached to it. And so, if I look at the actual mesh component, it's got this material instance color only on it. So what that actually is I've created a material called color only, and it has a material instance attached to it. So I've taken just a color node that's a parameter, put it in the base color, and that is it. It's color only. That's kind of why I called it that. But when I use this set vector parameter value, something kind of important to note is that material instances actually have two different types. There are constant material instances, and then there's dynamic material instances. So yes, when I'm inside editor, I can use this, and I can directly affect the color on the cube if I wanted to, which is great. That's all good. However, that may not exactly be what I'm after in this case. So let me just make it a little more obvious what's going on. So, and the reason for that is I want to be able to change this at runtime, which is when DMX happens. And if I'm using this material instance, I can't actually do that in the same way, because it's compiled basically at begin play, like before, and then that's it. Like once it has been compiled, like you can't change any of these values again. So there's a few ways to deal with this. And so I'm going to show you a couple of ideas on how to deal with it. The first way is exactly how I did it here. I'm going to set the vector parameter, and I'm going to pick the static mesh component, and I'm just going to pass in the parameter name, which is color. And if you're wondering where that name comes from, that is literally what the name of this is. So this name needs to match this name. Now, when I do this, it is automatically going to assign a dynamic material to this, and I'll show you kind of what I mean. So when I hit play, if I go and I look at that, you can see it says material instance dynamic 0. It has already done this because it knows, based on what I'm doing, that this can only be done to a dynamic material. So it's going to do it for me. You can specify your own, and there's documentation on that, but it actually does the job here. And so if I grab, one of these things and start punching away on it, I should see something. However, I'm pretty sure I didn't actually set the DMX address. So if I go back to, let's put this on 2 so we can see the difference between that and the scene color. So if I grab just RGB2 and hit red, I get red, amber, blue. But you'll notice too, like every time, it creates this dynamic material instance. And this is great because if I create another one, and just copy it basically and just change the address, now when I hit play, I'm gonna have dynamic 0, and a new one should be created as well. So if I were to play with 3 and change it to yellow, or 2 and change it to amber, it's fine because they're actually different dynamic material instances, which is pretty nice, honestly, that I don't have to worry about that part of it, and it's just going to kind of deal with that on the back end. But this isn't, again, always a very efficient way of dealing with things either. It is efficient because I made a material instance that's using dynamic materials, but if I wanted to affect lots of different things with the same DMX parameter, this isn't necessarily going to get me there quite as easily as maybe some other methods. So I'll show you another idea of kind of how you can do this, and we're going to use what's called a material parameter collection. So to create one of those, you right click, you go to materials and textures, material parameter collection. Once you create one, you'll get a window like this, and it'll probably be collapsed like this. And so what I'm going to do, what I did here is I created 2 vector parameters. So when I create them, it's going to make a vector 4. I named it color 1 and color 2. And then the scalar parameters, I was just kind of playing around, and I made like 3 separate ones if I wanted to try and tackle it that way, but I'm not going to do that. So then I have this other material, basic color, and now instead of plugging in and just doing like, if I did a vector 4 and went to plug it in, instead of doing that, I'm actually going to use this material parameter collection node. So if I were to type that in, it's actually called collection parameter. And so if I then specify which one I want, I can then get a drop down of those options. So either scalar values or vector values. So in this case, I'm using vector value color 1. And so this is how I'm going to drive this. And I could actually use this same material parameter collection in other places. Like I could plug it in the emissive, or I could plug it into other things, other UI elements, whatever it is. And there's lots of different options for this. But the other good thing about this is I can modify this at runtime and when I'm inside the editor. So it kind of gives you a little bit more flexibility depending on what you're doing in this case. So I made a material instance of this again, and what I'm going to do is, instead of using these 2 blueprints that I made earlier, I'm literally just going to grab a brand new let's just go with a cylinder, so maybe it looks a little different. Change it to movable, and then I'm going to apply that material to it. So I'm going to grab the instance, I'll put the base color on it, it's going to be black, like all that's great. And so now you'll notice something different about this, like I'm not actually using, I don't necessarily, hold on, actually that's not true. I can definitely affect the parameter collection, but I still need to do it somewhere. So I can either do it in, again, player controller, level blueprint, editor utility widget, but in the interest of time, I am actually going to use this cube blueprint, and I'll just paste it on there. So if I put that in there, it replaces it, it's fine. That way I can still use this DMX component. It'll just make it go a little faster. So I put that on RGB2, that's cool. So I do this, I grab RGB2, and nothing's happening because I didn't actually change the way this works inside here. So let's go back. So instead of doing it this way, I had already made this down here. So all I really need to do is hook this and this up instead, right? So I'm going to, instead of using the previous way of doing it, I'm going to use this. So instead of setting the value on materials, I'm going to use this set vector parameter value for material collections. So when you type in set vector, you're going to see a few different options. So you can get this one, and if you read the description, it will say material collection, and this one is for it says target as mesh component, but really this really means it says it over here as well, but it's for dynamic materials instances. So now what I'm going to do is I'm going to remove this execution pin and stick it here, right? So now I'm using the same find and all this, but I'm just going to make a linear color and plug it in here. Now something that is going to be slightly different about this is well, I'll just show you. So colors don't actually use 0 to 255, right? There is only inside of Unreal anyway. So if I start punching away on this, it's fine, but you'll probably notice if I go to something like red and I start dialing it down, it doesn't really do anything till it gets all the way to like 0. You can't even make any adjustments. And the reason is because there's a mismatch here on what the range is on this. So DMX is 0 to 255, colors are 0 to 1 float values. So we have kind of two ways we can deal with this. The simplest way to do it is actually just to divide. So I can say float by float, and I can type in 255, right? So if I do that and plug it in here, and then just make 2 copies of this. Same thing. Okay, so now I'm just doing this. And if I hit play, now when I go into this and I grab this red and I were to dial it down, I'm actually getting like a dimming effect, right? Because it's converting from, its previous range of 0 to 255 into a range of 0 to 1, which is what this color wants to see. So that's one way to deal with it. Another way to deal with it is to actually use a range. So there's two different ones we can actually use. So we can do map range clamped or unclamped, clamped or unclamped. And then there's also a value to normalize the range. So it kind of depends on what you're doing. In this case, the probably way that I would do it is actually I would just use a clamped. So I would say, okay, my in range is 0 to 255, and my out range is 0 to 1. And this is going to do the same thing as dividing by 255, except I can kind of specify this later. And I'll show you where this might be more useful, because for something as simple as a color, I know what it's going to be. It's going to be 0 to 1. That's pretty easy for my float. But for other things, it may not be so cut and dry. So let's look at another example for something like that. So let's say I wanted to affect the position of this cube instead of the color. So what I'm actually looking for is I'm going to try and affect the X location, so forward to back in this case. And so there's a few different ways I could do it, but just building on the same blocks that we have already kind of gone over. If I go into this one, you can kind of see there's a lot of similar things in here, but the slightly different idea behind this is like we're going to be getting the location and setting location instead of a color. And location is, highly variable how much you want to affect, right? I'm only using an 8-bit parameter in this case, so I only have 255 steps. And if I were to just hook that up by itself, I'm not going to get a whole lot of movement, right? So I'll just do that to start with. So all I'm doing here is I'm going to get the actor location, which is referring to self. In this case, it's this cube. And I'm going to set that as a variable. So I'm setting that as a vector 3 in this case. And then I'm going to do the same thing where I get the patch from the component. And then I'm going to find listen 1, which is, in this case, that's what I named this way back when in my channel listen, I named the function name listen 1. Okay, so that needs to match. And so now what I'm going to do is I want to set this actor's location, right? So I don't want to move it on Y and Z. So what I actually did is I grabbed this current location. So if I do get, it'll look like this to start with, but if I split this out, I can affect them individually. And so I'm going to take my my X here, and I'm basically just going to replace it, right? So in this case, I'm not using this range remap thing yet, but I'm just taking the raw DMX value and I'm going to punch it in there. And so if I do that, what you'll notice right away is when I hit play, it kind of jumps around, and the reason for that is it just was kind of zeroing out kind of what it's doing, because I didn't actually add it to where it was. So if I grab the dimmer though and I just start dialing it up with the wheel here, I should be able to affect where this object is. But I have a couple ideas why that wasn't actually doing much. One, we probably wouldn't really see it much anyway because it doesn't have a whole lot of range, but I also didn't set the patch, which I tend to forget about. Alright, so all that's good. So let's hit play. We'll go back to canvases, grab the dimmer, and so now if I dial it up and down, yay, I'm getting my movement. But again, I'm capped at 255 total units here. And I can only go in one direction because I'm only giving myself that as an option inside of Unreal. So what I'm going to do now is, and this is something you might need to work on in your defaults with your console, but ideally, like with pan and tilt, you're starting at halfway. You're starting at 50%, right? That's fairly typical. So I'm going to leave that there, and what I'm going to do is instead of just feeding the raw value in, I'm going to use that range remap basically that I was talking about before, where I'm going to map the range, clamp it, and I'm going to give myself a range of negative 500 units to 500 units. So I basically have 1,000 units of range. So I'm going to take the current X location, add it, I'm using an add node here, to whatever's coming in from the DMX. So basically I've got its original location. I'm going to add to that its new amount that I want to affect it by. I'm going to punch that into X, and then we'll go back, hit play. All right, it shouldn't really move, hopefully. And then now when I move this, I should be able to go backwards and forwards by 500 units from where it was. Now, there's a couple of things to think about here. One, intensity is in percentages, which is, maybe not ideal for this. You might want 255. If you're using 16-bit parameters, you may need to adjust this. And again, this is why kind of thinking about this from the beginning might give you some better results, so that you don't end up with so many of these. Really, this should never be done like over and over and over again. I would think about this and say, okay, how many types of conversions am I going to do? I'm probably going to do one from 0 to 55 to 0 to 1, float value. One that'll just be straight through. One that I want to have variables set for these, so I can change this on the fly and have that also be in here. And so I would try and think of those things ahead of time, so you don't end up with too many different types of things just doing different things. But I just wanted to kind of give you some quick ideas about how this could work, and just some ways that you could hook this up in order to get like a quick result. But again, ideally you wouldn't have tons of different types of objects. You would have maybe one or two master types that would then be able to pass that the DMX values into these other ones. And so you would, in addition to maybe setting the DMX value, you would also have a way to set your range right on the thing, so that way you're not having to dive into the blueprint to change the range that you're trying to affect. Okay, so last thing I wanted to talk about was this idea of sequencer playback. So I created a level sequence, a really simple one, where I'm using this cone. And so if I open it up, I just have my sequencer docked down here. So if I scrub forward, let me back up a little. You can kind of see what's going on here. So it's literally just kind of going and making like an upward kind of loopy thing. Nothing too special about this. So, but what I wanted to show was how to just get DMX to maybe like hit the play button or the pause button or go back to the front. So in order to do this, you kind of need to know a little bit about how sequencer works, and just some of the syntax that's used for it. So I'm going to go through it super quick, but just maybe dive through that a little bit. So what I'm going to do in this case is use the level blueprint. And the reason I'm doing this is because I want to be able to affect it without having, just inside the level itself, without having to create a level sequence. And that there's a couple different reasons why I want to do this, but I really just wanted to be able to reference the level sequence, have a hard reference, because it just would make my life easier in this case. So all I'm going to do is just drag this out in here. I'm not going to have any of these things set because I can still override them, but I don't want it to affect the result here. And so if I hit play, nothing should happen to the cone by default. But what I've done inside the level blueprint is I've set up this so that if I use this third dimmer channel, I'm going to do this logic from this listen 8-bit. So I specified this directly because since it's in the level blueprint, there's no component to add, right? So I kind of have to do it this way. And I'm using here a switch on string. Now the reason I did it this way is if you use, normally you would probably use a switch on int, and you would add pins to this. But because dimmers are in percentages, and I wasn't entirely sure how to change this readout and stuff inside Canvas, and I wanted to show a different way of doing this. Every time I add a pin, I would have to add like hundreds of these things to get to the to get all of them. But I really only want to affect 3 values. So if I do switch on string, I actually get over here the option to type in the ones that I want. So I'm just converting from int to string, and then I'm going to switch what this execution is doing based on the string. Now there's a few other nodes you could use here. You could use switch on int. You could also use compare int node, which is kind of handy. So you can actually do greater than, equal to, or less than, and use that. That's kind of a handy one as well that I found for doing certain functions. But in this case, what I'm going to do is use 3 different nodes to control sequencer playback. So I've gotten a hard reference to my sequence, and then gotten these targets are movie scene sequence players. So it may not be entirely obvious the first time you try this, because if you just type in play, you're going to get like 100 different options that you may not know which ones they go to. But in this case, what we really want is, so if you were to type in movies scene, you're gonna get then the options for the movie scene options in here, and then from there you can kind of narrow down what it is that you're trying to do. But just know that like these are, even though it's called pause, there's a lot of different things that can pause. So you need to find the actual one. So in this case, it's actually game cinematic pause, right? That's the one we actually want. Same thing with play. So even though it says movie scene sequence player, really what you're looking for is the one that's inside. I'll just go back to. There's a lot more plays actually, but if you go to cinematic, if I start typing in that, it'll limit your search by that. And so we can set play. You can also set play reverse. You can do looping, and play 2 frames in seconds doesn't actually maybe do what you would think. It doesn't actually just start playing to that spot. It's a little bit weird, even though that's what it sounds exactly what it would do. It's really going to essentially play all of the events that are happening on the timeline up until that point. It's not actually playing. Going to tell it to play to that. There is a new function coming for this that will have that functionality, but for now, just trust me. So what we're gonna do is if we get 0 from this, we're going to jump to 0 seconds, meaning just reset back to the top. If we go to 25, which should be 10%, we're going to play, and if we go to 51, which should be 20%, we're gonna pause right where it is. So inside my level sequence here, I've set it to like inside here, it's not saying to loop, but I believe it is going to loop just because I'm continually sending a play command to it. So even when it gets back around to the front, I'm just going to send another play command. And so that's why it may appear to loop, but really it's not exactly doing that. So let's just go ahead and I'll run it. So the cone shouldn't move. If I go to my canvases here, I'm going to grab that third channel I was talking about. And if I go at 10, it should start playing, right? And so if I kind of move back, you can kind of see a little bit more of what's going on, right? And again, it's not actually looping, but it's just because every time it gets back around, it's running a play command again. So that's why it keeps going back around. So if I wanted to pause it, so I'll kind of try and get it to pause in the middle, I can just say at 20, it pauses right where it is. If I were to clear everything, it's going to set it back to the front. And so this is one way that you can kind of deal with playback here. Now the way to deal with playing to marked frames, unfortunately, until the update for this comes out, the only way to actually do this properly is to set your end time, or your start time and your end time. And you'll have to do that programmatically. Now that's definitely a little bit more of an advanced topic that I'm not going to cover today because I just don't have time. Lastly, I was going to maybe, give an idea on how to play with DMX inside of editor. So I was thinking I would probably try and go over this, but really this is there's nothing different about it except we're going to use an editor utility widget. I kind of want to save some of this for my talk, so I think I'll probably leave it at that. But essentially, you can use an editor utility widget to run blueprint logic inside the editor and not have to be in play mode. However, there's definitely some caveats and things to that, so it might be good to go over that at another time. So hopefully you found this valuable. I kind of went through this really quickly, and I hope you're able to follow some of it. And get some ideas on how you might use a player controller or how you might use a blueprint, and define how you want to do this in different ways, also how to affect materials. So hopefully this helps, and we will definitely have more of this stuff coming in the future. Thanks.